I wasn't recording this, I'm sorry. Okay, so write a code to select the variables that contain the letter H in the Star Wars dataset. So to answer that, that's going to be Star Wars, and then our pipe operator. So percentage greater than percentage, select, and then contains, and then H. The bracket for contains, close the bracket for select. Okay. Okay, then write a code to filter observations in the orange dataset that have age greater than 500 and circumference less than 100. So that would be orange. And then put in our pipe operator. Then we filter. So it asks for age greater than 500. So we write age greater than 500. And we'll put our and there. And circumference less than 100. So that's our code. Okay. Write a code to change the circumference variable in the orange dataset to perimeter. So Fred, this is where your rename comes in. So our dataset is orange. And then we put in our pipe operator. And then it will be our rename. The new name is perimeter, equal to the old name is circumference. Okay. And write a code to change the value child to adolescent in the age variable of the Titanic dataset. Okay, so that's going to be Titanic. And then type. And then we're using mutate because record is a support function. So mutate. The variable is age. Okay. Equal to, we introduce our record function. We are working on the age variable. And then our old name is what? Child. Equal to our new name is what? Adolescent. Okay, so those are the answers to the questions of the last assessment. Is that clear for everyone?
Yes, sir.
Okay, awesome. So let's go back to our R Studio. So where did we stop? When data cleaning and manipulation. So let's just do a quick review. Can you list the functions we use in data exploration quickly? Anyone?
Okay, we have dim.
Dim, very
Okay.
good.
We have structure.
Structure, good.
We have class.
Class, awesome.
Name. Names.
Mm-hmm.
Head.
Head. Tail. Unique, very good.
Unique.
Mm-hmm.
Glimpse.
Glimpse, very good.
scheme, and
Scheme,
structure.
structure. Good. You also have summary,
view,
and view.
yeah.
Very good. Awesome. So then we entered into our data cleaning, and then we looked at clean names, which you said does three things. It converts all capitals to small letters. It replaces all spaces with underscores and replaces any special characters with underscores. And then we ran our clean names and saw what it does. And then we used our rename to change our variable names using this template here. And then we did our select, and we said select does one of four things. Anyone remember what select does?
Select wanted variable, deselect,
Unwanted
reorder,
variable,
and
reorders, and conditionally selects.
select, yeah.
Very good, Fred. That's good. Okay. And then we looked at our filter. So select works on variables, filter works on observations or rules, right? And then we saw how we could use our filter to filter specific values within variables that we want to see. And we also saw how we can combine different variables in the filter stuff. And then we also looked at how we use recode to change the names of values. Remember, we said the first four functions we treated, which are the clean names, rename, select, and filter, they are standalone functions. They can work directly into the pipe. But the remaining functions we will look at, they are all support functions. They work inside mutate. Okay, so we looked at recode, right? And then I think that was where we stopped. Okay, so the next function we're going to look at after recode is what we call FCT relevel. So I'm going to write that FCT relevel. So what does FCT relevel do? FCT relevel function, it rearranges values within a variable in the way that we want it to be. So I'll give you an example. Let's assume you have a data set that has marital status in it. Marital status will have things like single, divorced, widow, married, stuff like that. When you plot a table with that in R or any other statistical software, it gives you the values in alphabetical order. So for marital status, if you plot a table, it will start with divorced, which is D, and then married, which is M, and then separated, which is S, and then single, which is SI, and then widowed, which is W. So the way to give you this in the table is in alphabetical order. You can see D, M, S, S, W. But you will know intuitively, this is not how we want our marital status to be displayed. How do you want it to be displayed? We want it to be displayed like this. First of all, you're single, and then you're married, and then probably you get separated, and then you get divorced, and then widowed. So this is how we want our data to be displayed in our tables. But this is how R will display them as a default setting. So that's where FCT relevel comes in. So we can now arrange the values within that variable in the way we want it to be shown in our table. Let's look at the Star Wars data set, and I'll give you an example from that. Okay, so view. Oh, sorry. We just opened this and I've not installed and loaded my packages. So let's do that. Control Enter. Okay, and then let's look at our Star Wars. So let's view Star Wars.
Hello, I have a question.
Yes, go ahead, please. I'm listening. Go ahead.
Okay, my question is that I just noticed that on our console,
Yes.
all the things we did last time has disappeared.
Yes, that is why we encourage you to
So
do
how do
your,
you retrieve them?
that is why you write your codes in your script so that you can save it. So you can see this is our script in quadrant 1, and all the things we have written are still here. But anything you write in your console, by the time you close R and open it again, it all wipes off. So that is why you need to be writing and saving in your script in quadrant 1 here.
Okay, I see.
Yeah. Because anything you save in your script, you still have it. So you can see all the things we've done from the beginning is still here. From our title to our install and load packages, to our import data sets, data exploration, blah, blah. Everything is still in the script because you can save the script. But in the console, once you close and open, it wipes away.
Oh, I see. Okay, thank you for that.
So let's see. Let's look at this sex variable in the Star Wars dataset. And let's see how the table will look like. So let me come here and create a table. So Star Wars, put in my pipe, and then I'll select the sex variable, and then I'll plot a table. Okay, so this is a special table. It will give me the output here. So if I zoom this, you can see the table it gave us. You can see the values within the sex variable: female, hermaphrodite, male, non-unknown. You can see they are given in alphabetical order: F, H, M, N, U. Can you see that?
Yes, you can.
Okay. So let's assume this is not the way we want it. Let's assume we wanted to see none first, and then male, and then female, and before we have hermaphrodite. So we come here to, where is it? FCT level. Okay. And we say Star Wars. We pipe that into mutate. Remember, I said the remaining functions work as support functions in mutate. So mutate, we're working on what variable? The sex variable, equal to, our function is FCT underscore relevel. And then our variable is sex, comma, then we put in the values the way we want them to be seen. So we want to see none first, comma, and then we want to see male second, comma, want to see female as third, comma, and then we want to see hermaphro, how do you spell it again? Hermaphroditic. Hermaphroditic. Now, we don't include unknown. This is missing value because missing value is not a level. So we don't include it into the code. And then we pipe this into our select so that we can have a table, and then pipe that into TBL underscore summary, which is the table. So if I run this code, so you can see, let's zoom into quadrant 3. So you can see it has arranged the way we put it. we have none, we have male, we have female, we have hermaphroditic. Can you appreciate that?
Yes.
Okay, so this is how it was before. Female, hermaphroditic in alphabetical order. But when we use FCT relevel, we put it in the way we want it to appear. So that's how to use your FCT underscore relevel function, right? Are we clear on that?
Yes, but on the table, we
Yeah.
have n is equal to 87 raised to power 1. What does that one mean?
Okay, no, this is just telling us what this place is. This column. So it means
the column is
n
telling us.
n is the frequency in bracket percent. That is this 6 is the frequency and then in bracket percent. Just telling us what this column means.
The one, that's what I'm asking.
That's what I'm telling you now. This one is just telling it explains it here. You can see it here. It explains that one means that column is telling us about the frequency and the percentage.
Okay.
Yeah. Okay, so let's look at the next function, which we call the if-else function. So if-else function is used to recategorize a variable based on a binary outcome. So I'm going to give us an example. Let's assume in the Star Wars data set, let's assume this height here now. We want to categorize them into two. We want to categorize height into tall and short. And for those that are tall, those that are tall will be above 150. Anybody that is less than 150, we'll call them short. So that's a binary outcome, either tall or short, right? So this is how we put the code here. So we say Star Wars, put in a pipe, and then mutate. Remember I said it's a support function. So remember we said mutate can either work on the existing column or create a new column. So we want to create a new column. So we put in our, call it height underscore category. That's what I want to call the new column, equal to the change function we're using is if else, right? If else is working on which variable? Is working on the height. And what's the condition? We say if height is greater than 1, right? That's the condition, comma. So if this condition is yes, equal to, you call them tall, comma. If this condition is no, equal to, you call them short. So can you appreciate the code? We put in our Star Wars, mutate. The new category we want to find is height category, equal to, our change function is if else. The condition is height greater than 150. Now, if this condition is yes, we want R to call them tall. But if this condition is no, we want the R to call them short. We use if else for a binary outcome, either a true or false or yes or no, just two options. That's why we use if else. So if I do this, Control Enter, no, let's view it in the source quadrant. So let me view it. Control Enter. So because we asked R to create a new column, you can see the existing column, the height is still here. And then what it does is that at the end of the data set, that's where it puts the new column. And you see at the end of the data set, see our height underscore category. So it has converted them into tall and short. But let me add a code so that we can only view the two columns that we're interested in. So let's come here and say select the height and the height category. And then let's view that. Let's put in our pipe and view that. So Control Enter. So it has just selected only the two categories where we're interested in. So this is height and this is height category. So those that are above 150, you can see 167 is above 150, 176 above 150. It calls them tall. 96, however, is below 150. It calls it short. Does that make sense to us? Hello, do we understand this?
Hi.
Sorry, did you say
I'm
yes?
trying to, I can hear you. I'm just trying to make sense of the whole thing, though.
So, but you still remember how we use our mutate, which you said either we use here, either we use the existing column or a new column, right?
Yes.
Good. And then you still remember that after that, the next thing I want to see is the change function. The change function that we're using here is if else. Just like in the last one, we used FCT relevel. Just like in the first one, we used recode. This place is your change function. So how if else works is that you give a condition. This is a condition. And so if that condition is true, that's yes. If this height equal to 150 is yes, it's true. Call them tall. However, if this height greater than 150 is not true, which is no, refer to them as short. That's what the if-else function basically does. You give a condition, and then if that condition is true, what do you want them to be called? If that condition is false, what do you want them to be called? Does that make sense?
Yes. We are following small.
Okay. By the time you watch the video and then you type it to yourself and practice, it will start making more sense to you. Okay. So that's your if else. So let's take another example of if else. So let's assume, what is our Star Wars data set? Let's assume this mass, right? We want those that are above 100 to be called heavy, and those that are below 100 to be called light, right? For the mass. Above 100 heavy, below 100 light. So the same thing, we put in our Star Wars, type that into mutate, and then we have a new category. Let's call that mass underscore category, a new column. And then we put in our if else. So the condition is what? Mass is greater than 100. That's the condition. So, comma, if this condition is true, which means yes, call them what? Heavy. If this condition is false, no, call them what? Light. Right? So that's the end of the code, but because we want to view it in the source quadrant, I'm just going to add to select only those two. If not, it will give us the entire data set. So we select mass and mass category, and then we view it so that we can see it in our source quadrant. So Control Enter, So you can see mass and mass category. Any weight that is above 100 is heavy. Those that are below 100 is light. Can you appreciate it?
Yes.
Okay. That's good. So remember we said if else works on a binary outcome. So only two conditions, either yes or no. That's only two conditions. Sometimes you might have a case where you are dealing with more than two outcomes, right? So let's assume, for example, in our Star Wars, let's assume we want this height to be in 3 categories. We want tall, average, and short. So now we have exceeded 2 categories, so we cannot use if else. Tall, average, and short. That's 3 categories. So in that case, we don't use if else, we use a function we call case when. So case underscore when function. So it's used to recategorize variable based on multiple outcomes. So once it is greater than 2 outcomes, where we use if else, we have to use our case when. Okay, so we have less than 2 minutes to the end of this session. So, and case when is a bit long, so I'm not going to start that now. We're going to start it in the next session. So any questions with what we've done so far? We've done if else, we've done FCT re-level. Any questions thus far? Any questions, Fred? Any questions, Alu, Josephine?
No question from my end yet.
Okay,
Just trying to figure out the whole thing.
it's all right. So I'm going to stop my share now, and then we'll continue in the next. Mr. Sam is here. Mr. Sam, welcome. I didn't know you had joined. Mr. Sam, can you hear me? Mr. Alu, good afternoon.
Good afternoon, sir.
Yeah, welcome. How was your week?
I thank God, sir.
Okay, that's good. I learned your defense is this coming week.
Yes, sir. Yes, sir.
I hope you guys are ready.
I'm preparing well, sir.
It's all right.
Yeah.
Okay, I'm going to end the session and then we'll continue in 10 minutes time.
All right.